All right, so let's get started, so we can just get knock this out, Been able to do it pretty much in 30 minutes with each class, so as long as we can do that, then we're good, okay? So the first thing.
Hold on. Alana's, she coming.
That's all right. Well, the first thing that I want you guys to write down, the keywords for today, which are exponent and base. Those are the two things we'll be looking at. Exponent and base. Make sure to write those down and leave a little bit of space for a definition. Okay, so the words are on the chat, just in case, but exponent and base. Okay. So I am gonna be recording this, so just so I can post it on the Google Classroom in case you guys missed something. So make sure nothing inappropriate, no rude comments or anything like that. And you guys can either have your mic on or have it off, as long as there's no like distracting background noise. Okay. But anyways, so let's go ahead and start with let's say the whiteboard. And so first off, we have a number in, let's say, 2 to the 5th power, right? Actually, before that, let me see. So let me just ask this: when we take the power of something, what does that mean? Okay. And just go ahead and unmute so you can answer really quick. What does it mean when we take the power of something? Anyone? All right, well, if we take the power of something, that just means that, we're multiplying it by itself a certain amount of time, right? Okay, so for example, let's say we have let's talk about what the base is versus what the exponent is. And now I'm gonna share the screen. Okay. Which one of these is a base and which one is the exponent?
The base is 2, the exponent is 5.
Right. So the base is 2 and the exponent is 5. The base is a bigger number, which tells us that, okay, it's 2, and the exponent tells us how many times we are going to multiply it by itself. So that's 2 times 2 times 2 times 2 times 2. So that's 2 multiplied 5 times, okay? Now, the biggest mistake, right, that students always make is that they want to do 2 times 5, right? That's not correct, right? So 2 times 2 times 2 times 2. And, we can just do it little by little, so it's 4. And then 8. And then 16. And finally, our answer would be 32. Okay, so that's 2 to the 5th power is equal to 32. Okay. All right. Let me know when we can move on.
I'm done.
Okay.
I'm done.
Yep. Okay, give you guys a couple minutes. And remember, I'm recording this, so it'll be on the Google Classroom in case you guys miss anything, okay?
Okay.
Good.
So let me clear it. So next example, let's say we have 3 to the 4th power, right? So that's the same thing as saying 3 times 3 times 3 times 3, 4 times, okay? And we evaluate it the same way. So we first do 3 times 3 gives us 9. And 9 times 3, which gives us 27. And 27 times 3, which would give us 81. Okay. Now, a couple of things that we need to know. Yeah. And this is part of what I call hidden math, right? It's math that is there, but we don't see it. Or hidden math or invisible math. If I have a number, let's just say I have the number 5. Okay. Does an exponent exist there?
No.
No. Yeah.
Gordo, you said yes?
It's 1,
Right.
right?
You're right. 5 to the 1 power. Okay? That's what I call hidden math, right? Even though it doesn't say it, it's there. 5 to the 1 power, because 5 to the 1 power is still 5. Okay? So that's one really good rule that you guys should always remember. Okay? If we have a number by itself, we assume that it's to the power of 1. So same thing if I had, I don't know, let's say I had 1,000, right? We can assume that there is 1,000 to the power of 1, because that's still 1,000, right? And another big rule that we should learn in algebra, another big rule we should have learned in algebra, but and we're going to continue to use in algebra 2.
Okay.
5 to the power of 0. When something is to the power of 0,
Isn't
what
it
does that
0?
mean?
So 0.
And actually, that's the biggest mistake made. 5 to the power of 0, it's actually not 0. 5 to the power of 0 would be 1. Anything to the power of 0 is 1. It doesn't matter what it is. I could say 1 billion to the power of 0 is equal to 1. Okay, that's another very important thing to remember. And here's the reason why. I could explain it. Let's say we have x to the 4th power divided by x to the 4th power. If you remember from last year in algebra, when we divide two things with the same base, what do we do with the exponent? I know it's a little hard to remember, right? But
wouldn't you combine it?
Well, we do combine them, right? But that's pretty good, Elijah. But what do we do? What do we specifically do with the exponent?
In front of the X.
You multiply.
Devin said add them. It's actually the opposite. We are going to subtract them. So x is 4 minus 4. But yeah, good job, Devin. I mean, it's the other way around, but you're on the right track. So 4 minus 4 gives us 0, right? So anything to the power of 0 should be 1. And so x to the 4th divided by x to the 4th, that's the same thing as we were to say, I don't know, 6 divided by 6, right? If we do 6 divided by 6, what's the answer there?
6 divided by 6. That's 1, isn't
That's
it?
1, right? Anything divided by itself is 1. So 7 divided by 7 is 1. 9 divided by 9 is 1.
Mhm.
So that's the exact same thing that you see here. 6 divided by 6 is the same thing we have here. If the numerator and the denominator are the same, the answer is going to be 1. So that's where we get the 0 being equal to 1. Okay?
Yes, sir.
You guys got that?
Yep.
Mm-hmm.
Can I erase it?
Mm-hmm.
Mhm.
Okay. Okay, next thing we're going to talk about that we always need to remember is our order of operation. Okay. Anybody tell me what the order of operation is?
Please excuse my dear Aunt Sally.
What was that?
PEMDAS.
PEMDAS? I don't know. I've always known it as please excuse my dear Aunt Sally, just like John said, right? That's the way I always learned it. Or remember we did something, remember we did those PEMDAS mobiles last year in class where we had the letters and then we just hung them on a string. Do you guys remember that?
Yeah.
Yeah. Remember some of them were different, right?
Mm-hmm.
What was the difference? Instead of PEMDAS, we actually flipped these around, right? We said, right? So the reason why I say that is because, you know, PEMDAS is a little bit like misleading, right? Because this is multiply and divide from left to right, or add and subtract from left to right. But if division comes first, then you do division before multiplication. If subtraction comes first, then you do subtraction before addition. You see that? So I teach you guys both these ways so that you know that whenever we're moving from left to right, you're either going to do multiplication or division first, whichever comes first, or addition or subtraction, right? Okay. But anyways, for now, you know, let's just practice. We're going to do a little bit of practice on the order of operation, right? So let's say we had 7 plus 3 plus 2 plus 8. Let's say we had something like this, right? Now, does the order in which we add them matter?
No.
Not necessarily, right? Because they're all the same operation, okay? But as practice, you know, you want to make sure that you're doing it from left to right, okay? So we're going to do 7 plus 3. That gives us 10. And 10 plus 2, which is 12. And 12 plus 8, which gives us 20. Okay? And this is how you should be showing your work as well, in this similar way, right? We do it step by step. We add one number, a couple of numbers at a time. Now let's say we had 10 minus 5 minus 3. And same question. Does the order necessarily matter when they're all subtractions?
Yes.
Actually, in this case, it really shouldn't matter either, right? Because, okay, let's say we have 10 minus 5. That's 5. And then 5 minus 3 is 2. Actually, yeah. Sorry, with subtraction, we do from left to right because it will matter. 10, because let's say we do 10 minus 5 minus 3. If we do 5 minus 3 first, that would give us 2. And 10 minus 2 would give us 8. So this is actually wrong, right? Because we started with the right part first. Generally, we always want to do from left to right. In addition, it doesn't really matter, but in subtraction, it will make a difference. Okay? So that's why I always say just start from left to right. You always want to practice it from left to right. Okay? So now let's say a little like a combination of everything, right? So 10 plus 7 minus 5 plus 3 minus 8, right? So combination of addition, subtraction. Now this definitely the order will also matter as well, right? So we want to make sure that we're doing this from left to right. Okay. So we start 10 plus 7, that gives us 17. And 17 minus 5 gives us 12. Then 12 plus 3, which will give us 15. And 15 minus 8, which should give us 7. That's your final answer. Okay. Pretty straightforward, but we just got to make sure that we remember this stuff, right? As we get into higher level math, we just need to make sure that our fundamentals are pretty good, okay? So last big question before we're done. And this is another one that gets students really confused as well. Okay. So can I clear the drawings? Are you guys good?
Yeah, I'm good.
Yes, sir.
Yeah, I'm good.
Yep. Okay. So the question is, oh my gosh. When we square a negative number, so, well, first off, what does it mean to square a number?
Listen.
Let's say I do 2 squared. What does that mean?
Multiply.
By 2.
Not multiplied, but we're taking the exponent
Divide.
of 2.
Right.
So if we say 2 squared, we're talking about 2 to the power of 2, which would be 4, right? If I say 5 squared, right? That's 5 to the power of 2, which is 25.
So that one is the one you do like 5 times 2 and 2 times 2.
No, because
No.
I know that can be a little bit confusing, but that's the same way, right? 2, this is the same thing as saying 2 times 2, but this is also the same thing as saying 5 times 5, not 5 times 2. Okay?
Oh yeah. Okay.
Safe? All right, good question.
Oh, so you would do it like 2 times, like 5 times. Never mind.
It's just a number by itself, right? Let's say I do 7 squared. What does that mean? That's not 7 times 2, it's what?
7 times 7.
Exactly. 7 times 7, which is 49. Okay? So it's just that when I say squared, it's another way of saying to the
You're
power
doing the
of,
same number.
yeah, to the power of 2. When I say cubed, do you guys know what that means when I say
Power
cubed?
3, right? Power
To the
3.
Power
third
of-
power.
To the power of 3. 3 times 3 times 3, which is 27, right? And then after that, we just say 3 to the power of 4 or 3 to the power of 5. There's no like words for that. But anyways, my point is, let me see. When I say -2 squared, what would that be? When I square a negative number, what happens?
It's
Actually,
a negative times a negative.
You're right. You're right. Exactly. That is a negative times a negative. Okay. And if we have a negative times a negative, what is going to happen?
Positive.
It becomes a
It becomes
positive.
positive.
Exactly. You're right. Good job, Lana. A negative times a negative becomes a positive. So whenever we're squaring a negative number, it's going to become positive. And the reason why a lot of students make that mistake is that they'll put it into the calculator and say, oh, we're going to do -3 squared. The calculator is going to calculate it and give you -9, right? And that's wrong. Here's the
You
reason
always
why.
use your parentheses.
Exactly. So here's what the calculator is seeing, right? -3 squared. So if you do 3 squared, that's 3 times 3, which is 9, but the negative is still on the outside. So -9, okay? So in the calculator, to be able to get it correctly, you have to do this, -3, sorry. That's gonna go in the outside of the parentheses. -3 squared, because then that tells you that we're doing -3 times -3, which is +9, okay? There's really no reason why a negative number should stay negative when it's squared. And we're actually going to talk about it in Algebra 2. That becomes something totally different, okay? And I don't really want to get into that because then it gets kind of confusing. But that's what it is, okay? Make sure you know the difference between outside of the parentheses and inside the parentheses, okay? All right. Okay, so I think that is all I got for today. Now, I wanted to show you guys how we're gonna be submitting our work, okay? So I want you guys to practice using Google Slides. I'm thinking about submitting work this way because even when we're back in class, I wanna make sure that, we're not, we're using as the least amount of paper as possible, so we're not like, handling a lot of things, So here's what we're gonna do. I'm gonna share the screen just so you guys can see, okay? So right now, I think at 1, the homework is gonna post on Google Classroom, and you're gonna get Google Slides, something like this, okay? And this is just an example, but let's say I'm gonna post the questions separately, and it's gonna be, I think you guys are gonna have maybe 10. They're gonna be 5 of them are on exponents, and the other 5 are on order of operation, okay? Adding and subtracting. So pretty simple. What you're gonna do is, let's say we have 3 to the power of 4, right? Let's say question number 1 is 3 to the power of 4, okay? So what you're gonna do is you're gonna work it out, and you're gonna say, okay, 3 to the power of 4 is 3 times 3 times 3 times 3, right? And that's, the answer to that should be 81, right? So first off, you're gonna put the answer right here, 81. And then on the right side, we're gonna put our work, okay? And there's 2 ways that we can do this. You can do it directly on your computer. If you, and it's not gonna let me show you because I'm using the camera for Zoom right now. But what you're gonna do is you're gonna come up here to where it says insert. You're gonna put image, and you're gonna put camera, okay? So you should be able to take a picture right here directly on your camera, on the camera on your computer. And all you have to do is, just hold it up and take the picture, right? And then you're gonna insert it directly into the Google slide. Okay, that's one way. To me, the second way, the easiest way, is to just do it on your phone. Okay, if you download the app on your phone, the Google Slides app, then what you're gonna do, and I'm gonna post up a video too about how to do this. It's a screen, I screen recorded my phone just so you guys can see it. But what you're gonna do is you're gonna say like, okay, I'm gonna go to the Google Slides app, and then I'm gonna go into the into the assignment. At the top, there's going to be an addition symbol. Okay. Then it's going to let you insert an image and then from camera. That way you can take a picture of the work. And then you can use that photo to put it directly onto the Google Slides. Hold on, let me. All right, sorry guys, give me a second. I went into the wrong one. Give me a second. Okay. So I took a picture and then I uploaded it directly into the Google Slides. Give me a second and there we go. Okay. As you can see, 3 to the power of 4, and then I just showed my work and then we got 81. And then we're just gonna put it on there. Okay. So each one of you should have your own copy of the slides so you can edit it. But to me, the easiest way is just to download the phone on your app. I mean, the app on your phone. Okay. Do we have any questions?
No, sir.
Nothing? Okay.
Shut up.
Let me see. Okay. So that should be it for today. Okay. Thank you guys for joining me. And yeah, just about 30 minutes. That's good. So for today, just that should be posted now in Google Classroom. So make sure to, you have until Friday to turn that stuff in, but it's better to just knock it out right now and get it over with. Okay. If you have any problems, let me know. But there should be videos on Google Classroom. I'm gonna post this video on there just in case you guys missed anything. All right. But other than that, looks like that's it for today. Okay.
Okay.
I'll see you guys tomorrow at the same time.
Okay.
Okay. Thank you so much. See you guys.